2.6, we're going to talk about transformations of graphs. So this is the same that you did in Algebra 2. So it's really a lot of memorization and just looking at an equation and figuring out what's happening to it. So here's an example of like everything put together. So if we multiply by a negative on the outside, that's a reflection on the x-axis. If we multiply by a number out front, it's a vertical stretch if it's greater than 1. Or it's a vertical compression if it's in between 0 and 1. So if it's like a fraction or a decimal, it would be a compression. If you multiply by a number inside, that's either inside the parentheses or inside the square root, whatever our parent function is, if you multiply by a negative on the inside, it's a reflection on the y-axis. And then a number on the inside is actually the opposite of what it is on the outside. So it's a horizontal stretch if it's in between 0 and 1. And then it's a horizontal compression if it's greater than 1. So inside, think opposite. If we add or subtract on the inside, it's a horizontal shift left or right. If we are adding, we go to the left. If we're subtracting, it moves to the right. And then if we're adding or subtracting on the outside, it's a vertical shift, so either up or down. If we're adding, we go up. If we're subtracting, we go down. So each page just explains each thing one by one, but it might help you on the homework to have this part open because it has all of them together. But it's really just memorization. So you guys got to practice so you know what goes with what. So reflecting the graph. So if we're reflecting the graph, it's when we multiply by a negative. If the negative is on the outside, it's a reflection on the x-axis. If we multiply by a negative on the inside, it's a reflection on the y-axis. If we add or subtract on the outside, it shifts it up or down. So if we add on the outside, we move up. If we subtract on the outside, we move down. On the inside, it's a shift to the left or right. So if we subtract on the inside, we move to the right. If we add on the inside, we move to the left. One way that I remember for this one on the inside, so inside's left or right, but if we have the word left, the word left kind of has 2 plus signs with the F and the T, if you want to think about it that way. Right also ends with a T, but left kind of has 2 of them. So think if it's a plus, you're moving to the left. So if we multiply by a number on the outside, it is a vertical stretch or shrink. So if it's greater than 1, it's a stretch. If it's in between 0 and 1, it's a shrink. So if you multiply by a number on the outside, it's a vertical stretch or shrink. Greater than 1's a stretch. In between 0 and 1, so if it was like a fraction or a decimal, it would be a shrink. On the inside, it's the opposite. So inside, when we multiply by a number, if it's greater than 1, it's a shrink. If it's in between 0 and 1, it's a stretch. So inside, when it's horizontal, it's the opposite. So let's look at example 1. We're just going to describe the transformations. It graphed it for us, but let's describe it. So starting with our parent function x squared. If I add 3 to the outside, which direction does that move our graph? It moves it up 3, perfect. So looking at our graph here, Starting with the blue one, which graph got shifted up 3? The red one, so this would be A, the red graph here. Looking at B, if we subtract 2 on the outside, what does that do to our graph? Moves it down 2. So starting with the blue graph, the purple one got shifted down 2. So this would be the graph for B. All right, example 2, same thing, we're identifying our transformations for A. When we add 4 on the inside, what direction does that move our graph? To the left 4. Plus is to the left. When we subtract 3 on the outside, which direction does that move our graph? Down 3, perfect. For B, when we subtract 2 on the inside, what direction does that move our graph? Right 2. And then when we add 7 on the outside, moves it up 7. All right, for example 4, when we multiply by a negative on the outside, so here it's the outside because we don't have any parentheses, we don't have any square roots, this would be considered outside. What does it do to our graph? It flips it, or in math terms, it's a reflection. A reflection on which axis? So outside would be what? X-axis or Y-axis? X-axis. Remember, you keep your ex-boyfriends outside. X-axis. Inside is a reflection on which axis? The Y-axis. Example 5. When we multiply, this is the outside because there's no parentheses or anything. When we multiply a number that's greater than 1 on the outside, what does that do to our graph? Nope, it is a vertical is on the outside, so it's either a vertical stretch or shrink. What do we think? Stretch when it's greater than 1. So again, 1/3 is on the outside, so it's going to be a vertical, but when it's less than 1, it's a shrink. All right, example 7 on the left here. When we multiply on the inside, so this is inside the parentheses. When we multiply on the inside, it's horizontal. When it's greater than 1 on the inside, what do we think? A shrink. Awesome. It's the opposite when it's on the inside. And then again, same thing for B. When we multiply on the inside, it's horizontal. But when it's less than 1 on the inside, what does that do? Stretch. So it's always the opposite on the inside. So we want to identify all the transformations. So for 1, be careful because this negative out front is separate to the 1/3. So when we multiply by a negative out front, what does that do to our graph? It flips it, so it's a reflection. Reflection on which axis? Outside. X-axis, perfect. What about when we multiply by 1/3 on the outside? Is it vertical or horizontal? Outside is vertical. Stretch or shrink? Shrink. It's 1/3, so it's less than 1. It's a shrink. All right, when we add 7 on the inside, what does that do to our graph? Left 7. Plus is left. And then when we subtract 1 on the outside, we move down 1. Let's do number 2. So for number 2, when we multiply by a number on the outside, what does that do to our graph? No. It's vertical when it's on the outside, because remember, think outside goes up or down, so vertical is up or down. Is it stretch or shrink? Stretch. because it's greater than 1. Now be careful on the inside. We have this negative here. A negative being multiplied on the inside does what? It's a reflection. Negatives are reflection on the y-axis is when it's on the inside. What about when we multiply by a number on the inside? It's horizontal, but when it's greater than 1, remember, inside's the opposite of what we think. So what would this be? Horizontal compression or shrink. Compression or shrink mean the same thing. Either way is fine. I don't know how WebAssign words it, but compression and shrink are the same. And then when we subtract 4 on the inside, what direction does that move our graph? Right. To the right 4, perfect. And then when we add 5 on the outside, what direction does that move our graph? Up 5. Awesome. So some of the questions will say, like given an x squared graph, apply the transformations moving to the right 5 and we'll say up 7 and a reflection on the x-axis. We have to write the equation. So some of the questions on WebAssign will give you the wording and you have to write the equation. Reflection on the x-axis. So just apply one transformation at a time. When we go to the right 5, what do? Awesome. It's minus 5 on the inside. So on the inside, I'm going to put parentheses. We have x minus 5. And that square just hangs up top. We don't do anything with it. It's just telling us it's an x squared graph. But we're going to put the parentheses there. We got to put the minus 5. Up 7, we do what? Where? Inside or outside? Outside, we add 7. And a reflection on the x-axis, put a negative on the outside. So this would be our equation. Because that's like the parent graph, so that's what we start with. Sometimes I think there might be a question on the WebAssign where it says like starting with a square root of x, where you just put the square root. If it happens on the inside, it would happen inside the square root. If it happens on the outside, it's outside the square root. Yeah. So that's like what you start with. That's your parent function, and then just apply everything to that. All right, 2.6, part 2. So we're going to be determining if a function's even, odd, or neither. So we can do this 2 different ways. If it gives us the graph, we can determine if it's even or odd by looking at the symmetry of it. And if it gives us the equation, we can do it algebraically. So if a graph is even, or if a function is even, it's going to be symmetrical to the y-axis. So if I put a line down the y-axis, this y-axis acts as my mirror. So it's going to be the same picture on the left and the right side. So this graph here would be even. If our function is odd, it's going to be symmetrical on the origin, which means if I take my iPad and I flip the graph upside down, we're going to have the same exact picture that we had before. So here, the top part is like a hill. So I would say the right part's a hill, the bottom part's a valley. So it's up on the right, down on the left. If I flipped my iPad upside down, it'd have the same picture. You can always screenshot it, flip it upside down.
My iPad's kind of buggy right now.
Okay. So this one would be an odd function because it's symmetrical about the origin. So if it's odd and symmetrical about the origin, you can always flip it. If you flip it upside down and get the same picture, it'd be odd. So in example 8, we're going to determine if the functions are even, odd, or neither algebraically. So what we want to do here is plug in a number and its opposite. You have to plug in a number that's greater than 1. So what's number greater than 1 that we could plug in? 2. Great choice. 2 is usually going to be the best choice because it's not that big of a number. So it'll be the easiest math to do. So we want to plug in a number and its opposite. If we get the same answer for both of them, it's going to be even. If we get opposite answers, it's going to be odd. And if we get totally different answers, then it would be neither. So let's do it for A. So I'm going to start by plugging in 2. We have 2 to the 5th power plus 2. What's 2 to the 5th power? 2 times 2 times 2 times 2 times 2.
16. Yo,
One more 2.
16 times 2.
32. So 32 plus 2 would be? 34. So we get 34 when we plug in 2. Let's plug in negative 2 and see what we get. So, yeah, you just can't plug in 1 because it doesn't work all the time with 1. So the next best thing would be to plug in 2. So 2 and negative 2 are always going to be the best choice. So negative 2 to the 5th power would be what? Negative 32, perfect. Plus negative 2, which would be minus 2. What's negative 32 minus 2? Negative 34. If we get opposite answers, what does that mean?
It's odd.
It'll be odd. So if you get the same number but opposite, so one's positive and one's negative, it's odd. Any questions here? Let's do the same thing for B. So what should we plug in for B? 2. So I'm going to plug in 2 first. We have 1 minus 2 to the 4th power. What's 2 to the 4th power?
16.
So 1 minus 16 is what? Negative 15. Perfect. Let's plug in negative 2 next. So 1 minus negative 2 to the 4th power. Be careful here. When you plug it into parentheses. You cannot make it positive. You have to do the exponent first. PEMDAS. You got to follow your order of operations. So we have to do negative 2 to the 4th power first. What's negative 2 to the 4th power? Negative 2 to the 4th power. 16. Write it out if you need to. Negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is what? 4. Negative 2 times negative 2 is 4. And 4 times 4? 16. What's 1 minus 16? Negative 15. So if we get the same answer, what does that mean? It's going to be even. Perfect. So when you get the same answers, it's even. Any questions here? Let's do the same thing for C. So we're going to start by plugging in what? 2 and negative 2. Perfect. So when we plug in 2 first, we get 2 times 2 minus 2 squared. 2 times 2 is? 4. Minus, what's 2 squared?
4.
And 4 minus 4? 0. Now let's plug in negative 2. So 2 times negative 2 minus negative 2 squared. What's 2 times negative 2? Negative 4. Minus, what's negative 2 squared? 4. What's negative 4 minus 4? Negative 8. Be careful with the math here. We get negative 8. So if we get totally different answers. Neither. It would be neither. Remember, if you get the same number but opposites, it's odd. If you get the same number exactly, it's even. And if you get totally different numbers, then it would be neither. So on the next page, let's determine if the function's even, odd, or neither by looking at the graphs. So on the one to the left, so the right part's going up and the left part's going down. If I flip my iPad upside down, will I have the same graph? So what do we think? Awesome, it's going to be odd. If you flip your iPad upside down, it's odd. Here, you can try flipping your iPad upside down. They both go down here. If I flip my iPad upside down, they'd both go up. So it's not going to be the same that way. But is it symmetrical about the y-axis? If I make the y-axis a mirror, do I have the same thing on the left and the right side? Yeah. Yes. So what would this be? Even. Let's check the third one. Is it symmetrical about the y-axis? No. I don't have the same thing on the left and the right side because the right side has more graph than the left. If I flipped it, it would be different. If I flip my graph upside down, do I have the same graph? So they both go down here. If I take my iPad and flip it upside down, would they both go down still? No, they'd both go up. So if it's not symmetrical about the y-axis and it's not symmetrical about the origin, what would it be?
No.
Neither. Perfect.